A robot rolls through a field at night. It's quiet, and under its chassis, industrial lasers flash in steady pulses. Each pulse is a decision. Weed, weed, crop, weed. No human is steering it. No engineer is pushing updates. The machine is deciding in real time what lives and what gets erased. This isn't a concept video. These robots are running right now on more than 100 farms in 15 countries, powered by something Carbon Robotics calls the large plant model. Think of it as agriculture's version of a large language model, trained on more than 150 million labeled plant images and field data points. That scale matters because it collapses what used to be a full engineering retraining cycle into something that happens directly in the dirt. Before this model, a new weed species or a familiar weed in strange lighting would break the system. Farmers had to collect images, send them to engineers, and wait about 24 hours for retraining before the robot could reliably target the plant. In agriculture, a day is an eternity. Now a farmer can point at a plant, tell the robot it's a weed, and the model updates its internal understanding almost instantly without fresh labels or retraining. It behaves less like a static classifier and more like it understands plant structure, species, and relationships, even when it's never seen that exact plant before. That shift from pattern matching to semantic understanding is the real story. If AI can operate in messy fields, what happens when the same approach moves into factories, warehouses, and homes? Because humanoid robots are finally crossing from hype to deployment, Chinese and US companies are announcing production plans, and UBTECH claims it completed the world's first mass delivery of humanoids, shipping more than 1,000 Walker S2 units into factories in 2025. These robots can walk autonomously, grasp objects, and operate in human-designed spaces. Battery life is still measured in hours, autonomy is narrow, and when they fail, remote humans step in and teleoperate them. Every intervention becomes training data, feeding the next generation of models. Automakers are using their own factories as test beds. Boston Dynamics and Tesla are running internal pilots, while Google DeepMind is working with Boston Dynamics on agents that reason about tasks instead of replaying scripts. Generative models are being plugged into control systems so robots can infer what to do when the environment changes. Put agriculture and factories together, and you see the pattern. Massive real-world data sets, models trained in messy environments, robots improving from reality instead of simulations. Physical AI is getting practical. On the consumer side, CES 2026 made it obvious robotics is moving beyond novelty. Dream showed a robot with an extendable arm that can pick up objects and clean corners traditional vacuums can't reach. Roborock demonstrated a stair-climbing vacuum concept that handles full-size steps. These are still pre-production, but they're manipulating objects, managing vertical space, and cleaning mixed messes like ketchup, soy sauce, and oat flakes in seconds. LG went further with its celluloid concept, which folded laundry, fetched drinks, and assisted in the kitchen, combining mobility and manipulation in one system. It's not shipping yet, and demos always involve theater, but it signals where manufacturers think the market is heading. Robots as a new appliance category, not just discs under sofas. Industry is treating robotics as infrastructure. NVIDIA is pushing edge hardware for real facilities where connectivity is unreliable and downtime is expensive. Partners like Boston Dynamics, Caterpillar, and Franka Robotics are building machines for cleaning, inspection, logistics, and operations. Jensen Huang has argued Europe's biggest advantage in the next AI wave is its factories, not software. The strategy is simple: fuse industrial bases with AI models and simulation, then deploy fleets of robots that gain autonomy over time. GPS-powered language models and specialized edge compute is now meant to power embodied AI. So this is where it converges. In fields, robots trained on 150 million examples decide what to do with plants they've never seen. In factories, humanoids walk, grasp, and learn from human teleoperators. In homes, robots are climbing stairs, moving objects, folding laundry, and cleaning spaces like they understand them. None of this is general intelligence. Every system is narrow and still dependent on humans when reality breaks expectations. But the direction is unmistakable. The gap between digital intelligence and physical action is closing, one deployment at a time.